So thank you very much for coming to today's class. The topic that we are going to talk about today is actually doing now data modeling in the MongoDB. So far we talked about the relational database, and last week we talked a little bit about the introduction to the big data. And from today we are going to actually utilize the MongoDB and try to do data modeling, and also we are going to talk about query in MongoDB later in today's class. So to do data modeling in MongoDB, last time I asked you to install MongoDB community server on your PC so that you have the working MongoDB server we can utilize today. And also I asked you to install Robo3t. Basically Robo3t is the free lightweight GUI for MongoDB with the embedded shell. What it means is that by installing Robo3t on your PC, basically it provides a client tool which you can utilize to connect to the MongoDB server, and you can also utilize MongoDB from this client software. So basically Robo3t is a client software from MongoDB, which is very similar to what was the software we used last time? I forgot the name. Oh yeah, it's very similar to the MySQL Workbench. So last time we used the MySQL Workbench, which is a client software for MySQL database. So the Robo3t is exactly the same. It's a client software we are going to utilize to connect to the MongoDB and do some operations. So for Robo3t, as I told you last time, you can download from their website, and it's free. So you don't need to pay any money for this. You can just download and install, and you may need to share email address when you are installing this Robo3t, when you are downloading it. So you can just type any email address that you don't use. So once you install the MongoDB community server and Robo3t, both of them on your PC, basically here is the step you can utilize Robo3t to connect to the MongoDB. So let's follow this together. So it's very simple. So first of all, I have to open Robo3t on my PC. So I installed the Robo3t here. So if I click this, the client software will be open here. So in my case, my Robo3t already detects my MongoDB installation. So it's shown here. But if you have your MongoDB installed correctly, but if your MongoDB connection is not shown here, you can click this create option, and you can make a new connection. So in my case, I already have this local DB here with the local host, and port number is 27017. So this is a MongoDB server port number. So I already have this connection here. But if you are sure that both of them are installed correctly, but if you don't see this connection option automatically showing up here, you can click this create here, create option. And then here you can set up the connection. So basically you can type localhost on the address. Localhost means your own PC. And you can type 27017 as a port number. And then you can click the save button. Then the local connection information will be saved like this. So this information is also shown on the slide like this. So basically it's this step, how to set up your connection. So if you see your connection, then basically you can connect to your MongoDB server. So here, if you see local database with the localhost 27017 port number, then you can click this and you can click connect icon here. So if you click connect icon, then your Robo3t will connect you to the MongoDB server installed on your PC. How do you know that? Because now you will see this information on the left sidebar. So if you see local database, and if you see the system folder and the configuration database, it means that you are connected to your local MongoDB server correctly. So make sure that you are able to connect to your MongoDB server from Robo3t. And if you have any problem or any questions, please let me know. if you connect correctly, then as I told you, on the left sidebar, you will see the list of database you have inside your MongoDB server. So currently, by default, you have a system folder and something like this inside the system folder, like admin database and the local database. And by default, so this is slightly different from the MySQL. So when we use MySQL, when you connect from MySQL Workbench, it asks you to type root password. But as you see now in the MongoDB, they will not ask you this kind of password. So there is no authentication for the local server by default. Later, you are able to create the user account and you can create the password for your database. But we are going to talk about that in the next class, not today. But just remember that by default there is no authentication. But we are going to, for the first few classes, for the next few classes, we are just going to practice it. So we are not going to set up any authentication for now. And basically, this is the what's happening. So as a user, you are going to use Robo3T by utilizing graphical communication. And then Robo3T will connect to MongoDB and they will do system level communication. So that's basically same as MySQL Workbench and the MySQL. So in this case, it's Robo3T and the MongoDB. So that's the first look of the Mongo database via Robo3T. So now let's talk more about MongoDB. The first thing when we are learning and when we are studying the new database system, what we want to understand is the data structure. How data will be stored in the database. So that's the first thing we are going to cover. And the MongoDB, the data records will be saved as a JSON document. So that's the data structure of the MongoDB. Then the question is, what is JSON? So we don't know this. So JSON refers to binary representation of JSON document. Then the question is, what is JSON? So JSON refers to JavaScript object notation. So if you know and if you are familiar with the JavaScript, then probably you have heard about JSON. So JSON is basically JavaScript object notation. It's about a human readable plain text format for expressing structured data with support in many programming languages. So basically, it's one way of representing data as a human readable format. So I'm going to show you some examples so that you have an idea how the data will be stored in the MongoDB. So basically, following the JSON structure in MongoDB, the document will be composed of field and value. Sometimes we call this as key and value. So in the MongoDB, when we talk about the data structure and the document, we use field and key interchangeably. So the term, it doesn't matter. And for each field, we will have a data. So that's how the field and value are determined in the MongoDB. So basically, this is one example of document structure in the MongoDB. So in the MongoDB, all of the data will be stored as a document structure which follows JSON format. So for example, this is one data which we can store in the MongoDB. And in each line, there is a field and value. So the first field in this document is name, and the value of name is Sue. And after first line, we use a comma and we specify next field. The next field is age 26, which is value, and then comma. In the next line, the field is status, and the value is string A, and comma. And there is a group field, and inside the group field, we have a list of elements as data, as a value, like this. So this is one example of the document structure you can save and you can create in the MongoDB. And let me give you more information here. And when you create this field inside the document, there are certain rules you have to follow. First of all, the document can be of any size. So if you remember what we talked about last week, in MongoDB, it supports flexible data modeling. So it's different from relational database. In the relational database, every row of data has a certain number of attributes. So that number of attributes is fixed, and the same for every row of the data inside the table. However, in MongoDB, every document can have different number of fields. So it can be any size. So that's the first rule. So there could be two documents, and the first document may have only one field, name, and the second document may have two fields, name and friend. So there is an inconsistency between these two documents, but that's fine because it's MongoDB and it supports a flexible data modeling. And the second rule is when you naming the field name is case sensitive. So if you use field name as a lower capital letter, and if you use a field name starting with a capitalized letter, then MongoDB will consider this field and this field differently. So this name field and this name field with a capital letter are considered differently in MongoDB. And the last rule is that we cannot have the same field. So if you have one field with a name, and if you create another field with the same name, then this is not allowed in the MongoDB. So every field name should be different in the document in the MongoDB. So those are some simple rules you have to be careful when you are creating a document in the MongoDB. So now let's think about this. So in the relational database, in each table, we have a number of rows of data. So each row represents one observation, and when we have multiple rows of data, we put them together and we call that as a table. So table contains multiple information. In MongoDB, each document is basically same as a row in table in relational database. So each document contains a certain data for a certain thing, and we have a number of documents, and we put them together, it becomes a collection. So collection refers to a set of documents. So in this case, we have multiple documents, and each document has name, age, status groups like this, and each document refers to information about the different customer. Then we put them together, it becomes a customer collection, something like that. And again, as I told you earlier, the document in collection does not need to follow the same structure. So every document in a collection might have a different structure because it supports flexible data modeling. So the first user document about Claudia, this document may have a field friend, but the next document about Leo, this document may have another field job, and it may not have any field about the friend. And another document may have name, gender, location like this. So it doesn't need to follow the same structure for different documents, even though they are in one collection. And these are some of the data types you can utilize in MongoDB. There are actually many different data types you can use, but these are some of the examples. So in the relational database, I also showed you some of the frequently used data type, and here same. So a field may have the value null, so null refers for a non-existing field. So if you want to make a variable like a field inside the MongoDB document, but you don't want to put any data, you can just set it as null. And also you can have a Boolean data structure. So Boolean is true or false. Then you can have a field and you can put true or false value. So it's a binary value basically. You can also have a number like this. You can also have a string data. And also if you want to have a date, you can add a date here too. So when you create a document, if you want to put the current date into the variable, into the field, then you can use a new date function like this. And also, because it's the MongoDB is the database for the big data processing, it provides more different types of data type. So if you are familiar with the Python or other programming language, then probably you know the list data type. So that's also supported. So one field may have a multiple values inside a list like this. So a field may have a list value assigned like this. That's also possible. And also, more powerfully, in a field, you can actually add JavaScript code. So you can create a JavaScript function, and you can add that into a variable. That's also possible. And another very useful and important data type we are going to talk is the embedded document. So this is also possible. So at first, let's just say that this is the document designed for a customer whose name is key. Then you will make a name field and you will put the value key. Actually, the comma is missing here, but we have to put comma here. And in the address field, you can actually add another document as an embedded document. So in this case, basically, this entire document is the main document for the customer key. And inside this document, there is an address field. And address field contains a value of another document which has 3 fields like this. Then we call this as an embedded document. So basically, this document containing street, city, country fields is another document which is embedded inside a field of a main document like this. So that is also possible. So we are going to talk about embedded document more deeply later because it's a very important kind of data structure in the MongoDB. So let's try to utilize Robo3T to create and do something. So first of all, before we create document or before we deal with any data in the MongoDB, we have to first create the database. So to create database is quite simple. So once you are connected to the MongoDB from Robo3T, on your left sidebar, you will see this local database. Basically, local database refers to the MongoDB server you installed on your PC, and you can right-click on this, and there is an option, create a database. You can click this, and then you can name the database name. Then you can create new database in your MongoDB server. So let's do this. This is a very simple step. So here, I am already connected to the database server, my MongoDB database server installed on my PC. So I can see this local DB here. So if I right-click on local DB, I can see that there is a create database option here. So if I click this, I can make a new database. So let's just make a new database with the name test so that we can just test something today. And if I click create button, then now you will see that on the left sidebar, after configuration database, the test database is created. So basically, test database has a collection function and user folder, and currently there is nothing inside here because we just created a database, but we didn't add anything yet. So that's how to create database in the MongoDB. So it's a very simple step. And once you create database, you can actually do something on the database. So if you want to perform some operation on database, you actually have to select a certain database on your MongoDB server, and then you have to go to the shell to perform some operation. So how to do that is this. So here, after creating the database, on the left sidebar, on the test database, right-click on it. And the first option is open shell. So if you click this open shell, it will show this screen here. So here it says new shell, And here there are some information here. The first one, it says local DB. Basically, it's the name of your connection. And second, it says localhost 27017. Basically, it's the information of your server connected. So you are basically connected to localhost, which is your computer, 27017, the port number of your MongoDB server. And the last one here is the database name, test database. So basically, in this shell, you are now connected to the test database inside your MongoDB server. So if you type some code here, and if you perform it, that will be performed in your test database server. So basically, that's the information. So that's it. So it shows server information and the database name so that you will know exactly where your code will be performed if you do some operation here in the shell. So it's a shell. So basically, it's kind of an area you can code something and you can perform some operation. And in MongoDB, it supports JavaScript environment. So if you are familiar with the JavaScript coding, you can actually code some JavaScript here and you can perform it. So in this shell, you can interact with the database. And once you type some code here, you can click the play icon on the top to execute your code. So basically, MongoDB is very different from the relational database. In the relational database, we went through conceptual data modeling, and we made relational data modeling, and based on that, we designed the database system. But MongoDB, we don't have those steps because it supports flexible data modeling, so it doesn't go through those kind of structured steps of designing database. So you just code here, and based on your code, it will be performed on the database, and you can create document and you can perform query like this. So again, I said that in MongoDB, it supports JavaScript environment. So that means that you can create and run a JavaScript code. And if you type some code here, and if you save it, you can save your script into JavaScript file, which has a JS extension. So let's try to type this code on your shell, basically. Let's just see how it works. So to get familiarized with your MongoDB environment, let's try this. Let's type some simple code. I'm not sure whether I can make the font size bigger. I'm not sure actually. Let me just type here. So let me just type what's written on the slide. Okay, so this is basically what I typed based on what's on the slide. So on the first line, I typed the print hello world. Basically, it's the JavaScript code simply printing the hello world, this text. And the second part, I typed the 1, 2, 3 multiplied by 4, 5, 6. And the last one, I put some first statement here. So I used the variable k equal to 0. So I defined the variable k, initial value is 0. And I used the first statement. And I iterate I from 1 to 100, and basically inside the variable k, I sum up all these I value. So basically, the last one, I'm trying to find a value, basically the sum, the value of summing up the number from 1 to 100. So if I So if you type something here, basically if you type JavaScript code, and on the top there is this play icon here. So if you click this play icon, it will perform the code you type here. So if I click this, it will give you 3 results on the bottom here. So there are 3 tabs now. The first tab is the result of the first part. So it says hello world. And the second tab is the result of the second part. So the result of 1, 2, 3 multiplied by 4, 5, 6 is this number. And the last tab is the result of the last code. So basically, when we sum up the number from 1 to 100, the result will be 5050, like this. So basically, that's the main environment of the MongoDB. So you can code anything using the JavaScript. And in this MongoDB shell, you can actually also interact with the database system. So the operation you can perform are these 4 things: CRUD, which is create, read, update, and delete information stored in the MongoDB. So we can create document like this. So first of all, let's try this. Let's try this code here. So basically define the test variable inside the MongoDB shell. And in this variable, let's assign this document. So in this document, there is a name field, address field, and address field contains an embedded document with 3 other fields. So let's type this. You can see on the slide page 13 into MongoDB. Okay, so basically this is the code which is on slide. So I type the same code, and once you type this, let's just see what happens when you click the play icon on the top. So if I click the play icon on the top, this code will be performed, and you will see slightly different results like this. So basically what's happening is this: when the result of your code here returns a document, then this Robo3T will provide a better graphical interface so that you can see how the document structure is designed. So if you look at this, then it says that there is one document here, and inside this document, it says there are 2 fields. So you can check it here. And those fields are the name field and the address field. So if you look at the name field, it says the value is key, so which we typed here. So key value is assigned correctly into the name field inside this document. And the second field is address. And here it says 3 fields. It means that this is embedded document. So if you open address field, it shows that inside the address field there are 3 additional fields. The first field is street with 12 Chakchung Street. And second field is city. Third field is country. And it has data as we assigned there. So basically, in this way, we can know the structure of this document. So that's all. So basically, that's how you can design the document in the MongoDB in Robo3T. And that's how you can navigate information. However, if you just create document, it will not be saved anywhere. So if you want to save your document, you need a collection inside your database. So collection is basically, again, a space where your document can be stored. So creating collection is quite simple. So to make a new collection in the MongoDB, basically you can right-click on the collection folder under the database. and then there is a create collection option. So you can click that, then you can create collection. So let's just see how to do that. So here in MongoDB, on the left sidebar, we have a test database, and under test database, there is this collection folder. So currently there is nothing. So you can right click on the collection folder, then there is a create collection option. You can choose that. And then here you can name the collection. So in this case, we can say customer collection. And if I click create, then now you will see that the number next to the collection folder is changed into 1. It means that there is one collection. So if you open the folder, it shows that there is a customer collection created. So that's how you can create the collection in the MongoDB. Another way is you can use the shell. You can actually code it. So instead of using the graphical interface, you can simply type db.createCollection, and you can name the collection name. Then this collection will be created when you click the play icon. So for example, here, so this is a code we are going to use quite frequently. So in the MongoDB, whenever you utilize the code, you have to always specify the DB. DB means the current database, which is this one, test. So your shell is connected to test database. So you are saying that in this database, what you are going to do is that create collection. And in this function, you are going to give a name of the collection as a parameter. So I say, I already made a customer collection, so I say customer2 collection. And then close parenthesis and finish this code with a semicolon. So it's a JavaScript environment. So when we finish the code, we have to use a semicolon. So after type this db.createCollection and collection name, if I click this play icon on the top, this collection will be created. So if I click this, now it says that as a result, it says OK. So it's performed correctly. So when you perform this on a shell, currently there is nothing changed on the here. So what you have to do is that you have to refresh your database status. So you can right click on the test database. Then the second option is refresh. So if you click refresh, your database will be refreshed. Then now it says that there are 2 collections, and the second collection you have is customer2, like this. So those steps are also again on the slide, so you can follow this later. Basically, that's how you can create the collection. Using either way is fine in this case. Okay, so in the robustity, the basic operation you can do are basically those things. So now once you have a collection, you can right click on collection and you can perform multiple operations on this collection. So basic operations are this CRUD, basically create document, which is insert document, and read, view documents inside the collection, and update documents what you already have in the collection, and the last one is delete, remove documents you have in the collection. So there are 4 main operations you can perform. And let's try do one by one to get familiarized with this system. The first one is insert document. So now you have a collection, you have a space to add a new document into the collection. So let's do this. Just right click on a collection and click insert document. Then you can insert one document at a time. So here, earlier we made the customer collection here, so we can right click on it. And there are multiple options. Let's choose the insert document. Then it shows this window here, and it asks you to type the document basically. If you define document here, and if you click save, that will be saved on your collection. So let's type what's shown on the slide again. So after I type this, basically field and value like this. If everything is correct, then you can basically click save to add this document into collection. So it shows the name, basically information where your document will be saved. So my MongoDB server on my PC, test database, and on the customer collection, basically this information will be saved. So type this, and if I click save button here, then that's it. It will be saved. So the one thing is this. So if you use this graphical interface, it's convenient to add a document. But the problem is that you can add only one document at once. So that's probably one of the problems if you have to add multiple documents at once. So there's also option to utilize a shell. So you can actually code something. So instead of using this graphical interface, you can just right click on a database and you can click open shell. So in the shell environment, you can insert one or many documents at a time by utilizing code. And the code you can utilize is basically insert function here. So you can start your code with the DB database dot name of the collection where you want to add a document. In this case, customer collection, and that insert function. And inside the insert function, you can specify the document you want to add. So if you just want to add one document by using this code, you can simply specify document here. If you want to add multiple documents, you can use the same function, but you can specify a list of documents here. Then you can add multiple documents at once. So we can also try this. Let's try this. So on the left side, there's this code. On the shell, basically you can define C1 variable, and inside the C1 variable you can assign this document, and you can use this insert function to add a document. And on the right side there's another code. You can define multiple documents, and you can add all of them together with the insert function by listing them inside a list. So to this very simply, so currently this shell is connected to the test database, so I can try this here. So specify the DB, and the name of collection that I want to add a document is a customer collection, so specify that, and the function I want to utilize is insert function. So type insert, and the document I want is a C1, so I have to define the C1. So C1 is basically document with the field name, key, and it's too long, so I'll skip this. I'll just make this name key. So I made one document and I assigned that into the variable C1. And if I perform this code, basically this document will be added into customer collection. So if I click play icon, yeah, that's done. And it says that inserted one record like this. So if I want to add multiple records, I can make more documents here. So in this case, basically I defined the three documents, C1, C2, C3, basically name Claudia, name Leo, name Barry, like this. And if I want to add all these documents together at once, I can use the insert function, and here I can specify these three variables with a list. So inside the list, C1, C2, C3 is there. And if I click the play icon, basically multiple tabs are shown for each document structure, and the last one says inserted one record. Basically it means that it performed this one, but actually if you see later, you will see that all these three documents are added into your collection. So you can try this later. So that's how to add documents using the shell. environment in the Robo3T. So now let's try this. So once you add documents into the collection, so your collection will contain multiple documents. The next step is that you want to see what's saved in your collection. Then you can do this. You can simply right-click on a collection you see on the left sidebar, and you can choose the option View Document. Then you can see all the documents in the collection. So for example here, we added multiple documents into the customer collection, so you can right-click on the customer collection. Then the first option is View Documents. So if you click this, it will display all the documents inside your collection. So if I click this, it shows that there are 5 documents we added so far. So if I open each document, you can see the details here. So basically the first document we added was a key with 3 fields as an embedded document in the address field, and the second one is a key, just name. The third, fourth, and the last one is just a document with the name Claudia, Leo, and Barry, like this. So one thing you notice is this. Every document will have this field when you open the details. So every document in the collection has this ID field, underline ID, which we didn't make it actually. So when we insert our document, we didn't make the ID field, but this ID field will be automatically made by the MongoDB to assign unique ID information for each document. So you don't need to care much about this. The MongoDB by default will create a unique ID for every document automatically. So that's just something you can consider. So this is a kind of a primary key. Yeah. And that's the user interface. Also, we can use the same thing. We can do the same thing in the shell script. So in the shell environment, we can use a find function or find one function to see what kind of documents are stored in the collection. So the function, how to use this function is the same. You can specify the db dot collection name, which is customer in this case, and that you can use the find function or find one function. So if you use find function, it will display all documents in your collection. If you use find one function, it will display the first document stored in your collection. So in the real world, if you have a MongoDB, then each collection will contain a lot of data. So you may just want to check how the data and what kind of data is stored in each collection. You can just use find one function to see the first document to have an idea what each collection is about. So this is very simple. So on the test database, if I open shell here, and if I just type db.customer.find function, and if I click play icon, basically the same thing happens. It displays all the documents stored in your collection. And if I use find one function, it shows the first document inside your collection. So that's you can try this later on your PC. The next operation is update. So updating, you can follow this way. So again, if you want to update a certain document inside a certain collection, you can right click on a collection first, and you can choose the option update document. Then the MongoDB the Robo3T will prepare this code. So you can change the value inside this code to make the update work. So let me show you here very simply how it works. So on the customer collection again, if I right click and if I click update document, then MongoDB, this Robo3T will open a new shell for that test database, and it will prepare this update code. And here you can change the value to design update code basically. So here I mentioned that for update function, GUI option is actually same as the share option, because if we utilize the share option, we have to code there. And if you use this GUI option, basically on the new share, it prepares some template code. So exactly it's the same. So if you just open share, you can design this code by yourself, or you can use the GUI option to design your code from the template like this. We are going to actually talk about update query more in the next class. But if I give you like a brief example, a brief introduction, basically the first update function has 3 parts. Here, first part, second part, and the third part. The first part, it says query. So here is the area you specify which document you want to update. So it's so you design a query here to find out what documents inside the collection you want to update. Second part is update. Basically, you have to specify how your document needs to be updated. And the third part is option. When you update the document, what kind of option you want to give. There are 2 options you can give. The first is multi. So basically, you have to choose whether you want to update only one document or whether you want to update multiple documents. Second option is assert. So you have to decide what happens if there is no match. So yes, let's say that you want to update a certain document in a certain way, but it is possible there is no document that matches your query. Then you can choose whether to insert a new document or not. So that's the last option. But we are going to talk more about this next class. And basically, this is what you can do in a share. So same. In a share, if you want to design your code by yourself, you can use a DB database dot collection name customer dot update function, and then inside here you can specify query, update, and option part. So for example, if I want to a document, let's say that in a customer collection, if I want to find document with the name Claudia, and if I want to add this friend information, I can design this query basically. So in the update function, on the first part as a query, I can put name Claudia. So find all documents with the name Claudia, and once you found this, update with this document. And then option is set here. But this one, I'll skip this for now because we are going to talk more about this in the next class. Okay, so that was the update, and the last one is the delete. So in the collection, we have multiple documents, and sometimes we may remove some of the documents, or we want to remove all the documents in the collection. Then you can use this remove option. So again, for delete, GUI option is the same as the share option because we have to specify a query, which means that we have to specify which document we want to delete. So you can just right click on a database, and you can choose the open share to create the share environment. And then there you can specify the code to delete all or specific documents in your collection. So if I want to delete all the documents in the customer collection, you can use the db.customer collection name.remove function, and you can use this open bracket and close bracket. It means that you want to delete all the documents inside customer collection. If you want to delete a certain document, then inside this bracket, you have to specify which document you want to delete. So as an example here, if we want to delete document with the name field, and if the name field contains data key, we want to delete those documents, then you can specify field name value key like this. Then this second code will delete all the documents that satisfy what you specify here, which is query. And how to utilize query, we are going to talk more about in the second half of today's class. But the thing is this, just one thing I want to mention is this. In the big data system, like MongoDB, how you code things are very important and very critical. The main reason you are utilizing big data system is because you want to process huge amount of data in a fast speed. And depending on how you design the code, the speed of operation will be very different. So if you design the code in a more effective way, it will be fast. But if you design the code in a less efficient way, it will be slow. So here, there's one example here. Let's say that we have a certain collection, like a customer collection, and we want to remove all the customer information. Then you may use this code, remove all, like this. However, if you want to remove all documents in a collection, actually there is a better way. You can simply drop a collection. So there's also a drop function. If you use that, this customer collection will be deleted basically with all the data inside. And if you use this drop function, it will be much faster than simply deleting all the documents inside the collection. So let me show you the example here. So let's try to see the speed comparison. Let me type this code. You can try this later in your PC too. But let me type this code in my shell and let me create some database for the speed comparison. So let me type this first and let me explain. Okay, so let me click this to perform this query. Okay, so now it's worked, and let me refresh, and okay, I see these two collection here. So let me explain briefly about this code. So this is a basically simple JavaScript code. So if you are familiar with JavaScript, you will understand what this means, but you don't need to know JavaScript for this course. I'll just go through as an example. So what I'm doing is this. So I make two lists, L1 and L2. And I use this first statement and I iterate this statement for 50,000 times. And basically in L1 and L2, in these two lists, I add new document as this. Each document contains Su field and Bu field. So basically I'm putting just any data. So I make a document and add it in each list for 50,000 times. So basically L1 and L2 will be a list of 50,000 identical documents, and I add that into ABC1 collection using insert function, and also ABC2 collection using insert function. So basically I'm preparing some data for the test purpose. Here what I'm doing is that I create two identical collection, ABC1 and ABC2, and in each collection I added 50,000 documents. So that's what I did. So after performing this code, basically I'll have two collection which contains exactly the same 50,000 documents. And I want to test how the speed is different between performing remove function and drop function. So first of all, here I can make a new shell for the test database. And the first one I can try So basically, it's very simple. The first code is that in the ABC1 collection, there are 50,000 documents, and I want to remove all. So I test that. So type this code, remove all, and on the top, I click the play icon and perform this code. So it takes some time, and as you see here, this code was performed, and it removed all 50,000 documents from ABC1 collection, and it took 0.827 seconds. So that's what you can see. And the second shell here, I basically want to do the same thing, but instead of using remove function, I use drop function here. Basically, using drop function, I simply remove this collection. Then later I can make it again. And if I perform this code, it's much faster, as you see. It takes only 0.003 seconds. The difference is this. Basically, the main difference is that if you use remove all document, basically the MongoDB will go into collection and it will check each document and it will remove one by one. But if you use the drop function, it will simply delete the entire collection at once. So that's why the second code is much faster. And when you think about like a big data system, this kind of speed comparison is very important because you want your system to be performed as fast as possible. So this is one example of the speed comparison depending on how you code your system. So here is where this big data fallacy comes actually. So sometimes people say that in the organization or company, they have a huge amount of data, so they gathered a lot of data and they want to do something and they think their system is slow. So they believe that if they adopt a big data system, it will increase the speed. However, that's not always true. It's not like magic. So I have seen many companies, they are adopting new like a big data system into their database system or other parts of their organization. However, sometimes it actually slows down the process because they are not utilizing big data system well enough. So that's why this is very important. Just utilizing big data system is not working well. You have to understand how the big data system is processed, and based on that, you have to utilize it appropriately. Then you can actually get the benefits by utilizing big data system. So this actually applies how you do data modeling in MongoDB. So earlier I said that, and also last week I said that in the MongoDB and the big data system, we provide flexible data modeling, and we don't go through structured data modeling process. So in the big data system, there is no conceptual data modeling, there is no relational data modeling. So it's not like a relational database, we go through the structured process. So it's more like coding, so you can design the data structure as you wish and as you want. So there is no like structured steps. So you have a freedom. However, that means that you have to be more careful when you design the data structure, because depending on how you design data structure, the speed of the operation may change a lot. So here is the one example. So let's assume that we want to keep this information. So we want to keep customer information such as a name and more detailed customer information. And also we want to keep phone number information of those customers. Then in the MongoDB, there are two design choices we can utilize. The first one is embedding. Basically, in the embedding approach, we create customer collection. And in each customer collection, we create a customer document for each customer. And we can simply embed a list of phone number inside each customer document. So that's the one possible option. Another design choice is referencing. So it's similar to the relational database. We make a customer collection and the phone number collection separately. In the customer collection, we only keep the customer information like a name. And in the phone number collection, for each phone document, we add a phone number information. We also add a reference to the corresponding customer document. So reference means a customer name or customer's ID, something like that. Then this referencing approach is very similar to what we do in the relational database. Basically, in the MongoDB, if you follow these two approaches, depending on which approach you choose, the data structure will be different. If you choose embedding approach, your customer data inside the collection will look like this. There's a customer ID, there's the name of the customer, and you will create phone number field, and you will include a list of the phone numbers here. So every information is in one document. If you choose referencing approach, basically in the customer collection, each customer document will include customer information like ID, name, and the phone number information will be stored in the phone number collection as a separate document. So number 1, 2, 3, 4, 5 belong to customer ID 1. In another document, number 7777 belong to customer ID 1, like this. So in this case, which data model design should we adopt between these two choices? So that's just something you have to think about. So first of all, before we talk about and we compare these two design approach, let's just think about what happens in the relational database. So last week, I briefly talked about this. If we use a relational database to model this, we'll create customer table and the phone number table. So customer table has a CID and name. Phone number table has a phone number CID like this. And we use a referencing approach in the relational database so that this primary key will be linked to the foreign key in this table like this. And in the relational database, to know which phone number this customer has, we have to use the join. So basically using join, it will match data from 2 or more tables based on the same value in the column you specify. So we have this table, we use join based on the primary key and the foreign key. So that's what we talked last time. And then last time I basically gave you example of how the join works. So if we use a naive join, basically for each customer for CID, the MySQL will look for this CID match in the phone number table. So for each customer, it will scan the entire phone number table. So the total number of operation it will take will be n multiplied m if we have n number of customer and if we have m number of phone numbers in the table. So that's what we talked last time. However, relational database actually has been in the industry and used in practice quite a lot for a long time. So many people already developed the optimization process. So it's actually much faster than this. It doesn't take this long if you actually do this in the relational database. So they will use this concept of merge join in the relational database. What it means is that if this kind of join process is used quite often in your database system, the MySQL or other similar relational database will sort table based on the CID by default. So let's say that, so basically they will keep sorted version of your table. So for the customer table, it will be sorted based on CID. So they will have this table. Also for the phone number table, instead of this, the database system will have same phone number table sorted based on the CID. Then the table will look like this. So CID is sorted like this in an increasing order. If you have these kind of tables, then when you do join, it can be done much faster. So for example, when we do join between these two tables, first of all, we look at this customer, first customer whose ID is 123, and we'll try to find the matching phone number here. So the CID 123 is here, so we'll put this record here. CID 123 is here, so we'll put this record here in the result. And the next CID in the phone number is 274. Then we don't need to go through entire table. We can stop there because it's sorted based on the CID. If this number is already bigger than 123, we know that the other numbers will be bigger than 123. So we stop here. And then we go to the next customer. So next customer's CID is 274, and then we start from here again. So we match, then the result will be moved there, and it goes to the next phone number. This is bigger, so we stop here, and then we go to the next customer like this. So by doing this optimization process, we don't need to scan entire table for each customer. So we can increase speed a lot. So usually, if they utilize this kind of approach, optimization approach in the relational database, then the cost of doing the join in this case will be simply n plus m plus cost of sorting. But usually they will keep the sorted tables, so the total read operation cost will be simply n plus m. So it's much faster. So that's how the relational database increase the speed. So that's the reality. So then let's come back to the MongoDB in this case. So how long does it take to find the detailed information about a certain customer? So earlier, if we use join in the relational database, if we find a phone number for a certain customer, it will take n plus m time, basically. And how about these two approaches in the MongoDB? So first of all, if we use embedding approach, we'll have n number of customer in the customer collection. So there will be n number of documents. And in each document, we already have a list of phone numbers stored here as a list here. So to find the phone numbers for a certain document, we simply need to scan all the documents in a customer collection. So if there is n number of customer, by doing this query, it will take n number of read operation to find phone numbers of a certain customer. So in this case, it's much faster than the relational database, because the earlier relational database, it was n plus m. For referencing approach, if we use a referencing approach in the MongoDB, basically we have n number of customers, so we have to find the customer. So there is n number of operation we have to take, and for each customer we have to find the phone number. So we have to also read phone number collection. If there are m number of phone numbers, the total, if we use this query, the total operations we have to take is n plus m. But the tricky thing is this: I put the cost of additional request to the database. So usually, when you design a query, you will design either in relational database, also in MongoDB. Each line is query. So you will design one SQL in the relational database. In this case, we have to design two code. Basically, it's two query. So each query requires a processing of sending your query to the database system, and database system will process your query, and results should be sent back to you. So that's one trip. So in the relational database, because we use join, everything will be done in the server, and you will get the results after that. So you need to design one SQL, so you need one trip to the database server. But in this case, MongoDB doesn't have a join process. So you have to actually code, and you have to manually get the information from two different collections. So this is one query, one trip to the database, and there is another query, another trip to the database. So in this case, total read will be n plus m, but you actually have to pay the cost for one more trip to the database system. So if your system is huge, this additional trip to the database system, this cost will be also huge. So in this case, as a result, if you use the referencing approach, actually it will be slower than using relational database. So that's why just simply utilizing big data system does not help increasing the speed of operation. So you have to be very careful about how many operations and how fast the operation can be performed based on your design approach. So this is one of the main concepts, and something you have to be careful when you design the data structure in the MongoDB. So any questions here? So this is a very important thing. So whenever you design the database system, whenever you design the document structure in the MongoDB, you have to be really careful about your document structure and the design approach. Because again, MongoDB, you can design document as you want. There is no specific structure. There is no specific rule. So any document structure is possible, but you have to be very careful about the speed and the results from your document structure. So let's just think about this. Let's just think about the Twitter case, or something like a social network. So many social networks follow this kind of structure. So if we go to the user profile, like for example for Barack Obama in this case, we can see all of his tweets on his user profile. So let's assume that we want to design data model for user and tweet. So user means that there are some information about the user, like how many followers he has, and how many likes he has, and something like this. And also we want to have store this information about tweet from each user. Then in this case, should we use embedding or referencing? So which data modeling is better in this case? So let's think about each approach. What happens if we use embedding approach? So, basically, what happens if we simply include all the tweets inside the user document? And also, referencing approach means that we separate user document and the tweet document, and we use the referencing approach. So let's think about what happens if we use embedding approach first. So if we use embedding approach, basically we are going to design the user document like this. So we will not have any tweet collection because we will embed the tweets inside the user document. So in the user collection, for each user, we will have this user document. So user ID 1, and there will be like a name and other attributes. And for tweet, we will have the tweet field like this. And we will make a list of tweets, and we will add the embedded document for each tweet like this. The first tweet is a nice job. The share was this, number of like was this. And the second tweet was image, and share was this, like was like this. So this is the embedding approach. We simply embed all the tweets inside the user document. First issue is this. How many tweets will be there for each user? So over time, the number of tweets for each user will increase. There could be 1,000 tweets, or there could be million tweets, like if you are a very active user. So the size of the document will be very huge. And in MongoDB, there is this restriction that the size limit of each document is 16 megabytes. So basically, it kind of restricts that each document can grow exponentially. So basically, it will simply not work, including entire tweets inside one document. And the second issue is this. One of the very frequently used function on Twitter and social network is search. So you want to search based on some keyword or some tag. Then, what if someone searches over all the tweets? Then what will happen? The problem is this. This tweet information is embedded inside a user document. So to retrieve this tweet information, you have to retrieve this entire user document, which also contains a lot of information that you don't need. So whenever what you need is simply tweet, but you have to retrieve the bigger document. So it will slow the process. So the search is very not efficient if you use the embedding approach. Another problem is this. What if a user posts a new tweet? Then it will take more time. So to add a tweet here, basically you have to retrieve this big document, and then you have to retrieve this area, and you have to add an embedded document into this list. So to add a tweet, basically, the user information needs to be accessed first, and then the tweet info needs to be updated. So if you use the embedding approach, basically, the write operation will be slower in this case. So that's something you can expect. Then let's think about the referencing approach. So what if we use a referencing approach in this case? So if we use a referencing approach, basically we will create user collection, tweet collection separately. In the user collection, we will have a user document for each user, And in the tweet collection, each collection will be basically each tweet. So the one tweet will be about nice job, and share like number is here, and this is written by user ID 1. Second tweet, same, there is an image, and this is written by user ID 1 like this. The problem of referencing approach is this. When you go to the user profile, let's say that you go to the Obama's user profile, then we have to show Obama's information first, like what's the ID, what's the name, and what's the followers, and what's the followings, something like that. So we have to first search this user and access user information from user collection first. And then we have to search the recent tweets made by this user. So we have to also scan tweet collection, and we have to find the tweets written by this user, and we have to show that to the user. So basically we have to design two query in this case, and we have to send the two requests to the database. So it will be slow basically. However, in the online service, speed is very important. So when you click something, the user, they are very impatient and they want to see the result immediately. So referencing approach, it will provide a slow read speed, which will not be optimal for the online service with a huge amount of data. So what can we do in this case? So sometimes, actually in many cases, we utilize hybrid approach. We combine advantage of these two approaches together, so we make something like this. Keep recent tweets in a user document for instant access on user page. The nice thing about embedding tweets in the user document is that once you read that user document, tweet information is already there. So when you click a certain user profile on Twitter, you want to show the recent tweet together, then simply let's embed the recent tweets in the user document. So in this case, when we design the user document, for each user, we embed recent tweets here. So let's say that if we want to show 5 recent tweets of the user, then we can add 5 recent tweets inside user document like this by using the embedding approach. And then the other tweets, like old tweets. Like old tweets, we don't need to show directly when a user clicks a user profile, because those are old tweets. We only need to show the recent tweets. So for those old tweets, we keep them separately. So we use referencing from the tweet collection, and when a user requests to see more tweets from the another user, then at that time we simply search and provide more tweets when it's requested. So older tweets are stored separately in tweet collection like this. And then also it has advantage of search. So if the user wants to search over tweets, we don't need to scan this. We can simply scan over the tweet collection, so it will be fast to search a certain tweet information too. So by utilizing this hybrid approach, we can provide a fast read. So when a user clicks profile of Obama, we can show that person's information together with the recent tweet fast. So fast read operation is possible. And also, fast search operation can be provided because tweet information is also saved in another tweet collection. So that's how we can utilize the hybrid approach in this case. So this is something you will see usually. So usually, you can actually try using your laptop because everyone has a laptop here. You can just go to Twitter, and if you click a certain person's profile page, then you will see that this person's main information and the recent tweets are up here at the same time. And later, if you scroll down, you will see this kind of a circle like going around. So it makes you wait a little, and one more batch of tweets will be shown again. And if you scroll down again, it will search more, and it will show more batch of tweets later. So basically, they are utilizing, I'm not exactly sure how Twitter is doing, but they are utilizing similar approach based on what they are doing in their website. So recent tweets are probably saved together with the user information, and when you request more, when you see more tweets, they search over another collection and they show additional information. So that's how many online services are doing these days to improve the speed of operation. So that's the one example how you can utilize a hybrid approach. So basically, to summarize, between embedding and referencing approach, they have this kind of characteristics. For the embedding, usually it's good for small sub-documents. So when you have a small sub-documents which can be included together into the main document, you can use the embedding. There is no need for referencing. And you have to manage large sub-documents, it's better to separate so that the main document size is not too big. Also, embedding is good when data that does not change regularly. Because if a certain data is embedded, to change or update that data, you have to retrieve the main document first. So the process will be slow. So embedding is good for the data that does not change regularly. However, referencing is good for volatile data. So if the data should be changed regularly, it's better to be referenced so that it doesn't affect the main data. And also embedding, it's good for documents that grow by a small amount. And the referencing, it's good for documents that grow by a large amount. And also, data that usually often need to access together or shown together, then it should be embedded so that you only retrieve one document and the data is all there. So for example, like recent tweets, it's better to be embedded together. So when a user requests user information, you show the recent tweet together. However, data that you often exclude from the main results, you can maintain it separately by referencing. So like older tweets, you don't need to show it together with the main user information, then you put it separately. So overall, if you use embedding, it's good for fast read operation. If you use your referencing, it is usually good for fast write operation or fast search operation. So let's think about this. So for data modeling in NoSQL, what should we use between embedding and referencing for the following scenarios? So let's say that on the online social network, something like a user account preference. Is it better to embed with inside the user document, or it is better to separate from the main user document? Like, what do you think? Should we use embedding for this information or referencing for this information? How many think embedding might be better to keep user account preference information inside the user document? Okay, so yeah, some people raise hand. How about the referencing? Okay, so nobody. Yeah, so in this case, it's user account preference. So one thing is this, account preference. You have to think about the nature of this operation. So user account preference, once I set up some user account and I choose some preference, first of all, it's a small data, right? It doesn't grow over time. It's just a fixed amount of data. And second, account preference doesn't change regularly. Usually, you set when you like join or when you sign up, and you may change in the future, but usually people don't change that much. So this one, it's better to be embedded together with the user account, with the user information. And how about list of friends in social network? So list of friends in social network, should we put them together with the user account, or should we separate from the user account information? So how many of you think embedding might be better for list of friends? How many of you think referencing might be better for the list of friends? Okay, so more for referencing. Actually, I think in this case, it's a hybrid might be better. So, because sometimes when you access a user profile, we show some friends, right? First, like 9 friends or 10 friends, like recent friends first. So for listen to friends, we can do embedding, but for the rest of friends, we can keep them separately by using referencing approach. So in this case, hybrid approach will be better. So listen to activity. So I'll just do this by myself. So listen to activity is basically similar to the listen to tree. So listen to activity, we can do embedding, but the other activity, we can keep it separately by using referencing approach. So the last one, contents generated by user in YouTube. So what do you think about this? Contents generated by user. Should we use embedding or referencing? So how many of you think embedding will be better? How many of you think referencing will be better? Yeah, that's right. So in this case, actually the content itself is large, right? So actually embedding, if you do embedding entirely, it will slow down the process. So it's better to use referencing in this case because the size of content will be bigger in this case. Maybe something like a thumbnail might be included as embedding, but the content should be separated. So so that's it. So basically, to summarize the first part is this. So why do we use NoSQL? So we are using NoSQL and big data, big data management because it provides a flexible data modeling. And depending on how you design, the performance will be much faster. So you can have a great performance. However, you have to be really careful. Flexible data modeling doesn't mean that you can do anything. Actually, it requires careful thinking and creativity to maximize the performance of your code. So that's very important. So you have to have a full understanding of the real operation in the business. So how the certain function actually operates in the business system or application. And based on that, you have to design the data structure. So that's very important. So in NoSQL, actually data modeling is more of art than science. So flexible data modeling doesn't mean that it's actually easier. Actually, it's more complex and you have to think more